Hi, I'm Tim, and this is AIDE Template's final presentation. So the AquaClear Infrastructure Design Engine is the process we use for different communities of different sizes and populations that have different demands for drinking water that allows us to make tailored plans for each individual community. AquaClear AIDE, this template, redesigns 3D models on a program called Onshape. This allows us to make very, very dynamic and specific plans for every community we work for. As the name AIDE template suggests, we create templates of different plans. So you can think of this as us making the general shape of the plant, while the rest of AIDE designs the dimensions and actual flow rates that each plant needs. Individually, we all make different parts for the assembly as a whole, and together we put this together to make our final project.
So to accomplish this, we utilize the CAD software known as Onshape. And well, just as a refresher from our symposium, Onshape still remains the best CAD software for designing a plant for AIDE. And why is this? It's because Autodesk, AutoCAD, and Fusion 360 both don't have the optimal features for AIDE to function, whereas Onshape does. And a couple of advantages that Onshape exhibits over AutoCAD and Fusion 360 is, for one, just the version control and history system of Onshape, where similarly to GitHub, we can control our versions and see editing history for each of our components that we work on, which is very helpful for editing our parts and maintaining a good team organization. In addition, Onshape also just features all of them, common modern CAD tools, including just extruding, making sketches. But in addition, it also exhibits this sort of feature that we didn't have in Fusion 360, which is feature script. So feature script is effectively a coding language built specifically for Onshape that uses code to create each and every single one of our CAD models. In addition, this feature script can be used by other members in AIDE to create additional tools tailored specifically for designing our plants. For example, for the filter pipes, we can create a feature script tool that just takes lines that designate the center lines of each pipe and then automatically constructs pipes for each of those lines. So feature script is very beneficial for AIDE template as AIDE template's workflow, in addition to just basic efficiency of our designs, and is a very good reason why we continue to use this CAD software. In addition, AIDE template also, or Onshape also features configurations as opposed to the parameters that we used to use in Fusion 360. And configurations are much better suited to what we want to do with our parameterized plant model, as opposed to how they function in Fusion 360. It's much more efficient, and to change the dimensions of a plant, we don't need to change them in every single subcomponent and part. Instead, we can just change it in the top level, and it will affect the entire plant, which is much more efficient and just streamlined for AIDE templates its project goal.
So these configurations are essential to helping us make easily configurable and customizable models. So essentially configurations are variables that we can use to modify the dimensions of our parts. We can specifically modify individual dimensions such as length or diameter, but we can also create a sort of specific combination of configuration variables, and then we can create a number of these combinations that we can then switch between on the fly. Another nice thing about configurations is that we don't need to necessarily directly equate a dimension to a configuration variable. We can instead equate that dimension to a function of the configuration variable, which makes it much easier when we're doing larger assemblies, such as this SED tank. For example, these orange plate settlers here have a width that is directly equated to the inner width of the SED tank itself, whereas the number of plate settlers in the tank is configured in such a way that the maximum number, depending on the length of the said tank, it will be inserted and no more will appear. So it makes physical sense. And so just generally this helps us quickly and efficiently modify even the most complex of our models, and that's one of the reasons why we continue to use Onsheet.
Hi, my name is Elena. So we make parts and then drive them in part studios. We then move the parts into place so that they all fit together and are oriented properly. And we make different part studios for every major component of the plant. So for example, we take the concrete structure of the flocculator and combine it with the baffles to make the flocculator. So we originally were creating major parts using part studios because they were configurable, but part studios view a pattern as multiple different objects. So for example, this said tank that has less than like 20 different parts, the part studio views it as having 712 different parts. So creating these components in assemblies fixes this problem, but assemblies are not configurable, and we expect that the technology for configurable assemblies to come out in January. So this is a filter tank part studio, and this is a filter tank patterned in an assembly. So this is an example of how a part is patterned in an assembly, and we bring it over from the part studio and do all the patterning in the assembly.
So since the symposium, we've been finishing up all the major components in the plant. Over here we have the backwash filter. We have the set tank made in assembly now. We have the flocculator. We have a hinge weir, which is used in the filter entrance tank. We have a filter tank put into an assembly now. And we have the connecting geometry. Really, so this is a majority of all the components, so it's safe to say that that part of our work is done. However, we still have a little bit more to do. This is the connecting geometry. We're going to have to put in all of the different components to make it a full assembly. Past that, we're going to have to configure it, but that's not going to be available until January. Also, what we need to do is update the technology that Agua Clara has developed over the past 2 years that we've been trying to do this project. And then, obviously, when we're done doing that, we're going to have to test everything to make sure it works.
Jacob, I've been modeling the 1 liter per second plant, which is what Agua Clara developed for communities with access to smaller bodies of water. So this has been developed over the past 3 years, and it's really very new. So there's not really good solid documentation on what it's supposed to look like. There was a fusion model from last year, and when I first got assigned this project, I just kind of recreated it, but there's a lot of details missing. Like the plate settlers in here, you see, they're literally just floating there. And so I went to find the missing details. I looked through the documentation of when they manufactured it, and I found that that the whole manufacturing process was actually kind of complicated and had a lot of steps to it, and it's really not reflected in the model. So I realized that if we're going to make a model, it needs to demonstrate not only what the finished product looks like, but also what does the manufacturing process look like. So after I finished this, I created a new document and started making a much more detailed model that not only captures everything about the plant, but also everything about how it was made. So it starts with, I start with modeling materials as the people in Honduras building the plants would actually receive them. For example, this Fernco coupling would be a single part that you would receive and then you would attach to other things. So I'm created this in a part studio. No, this is my bad. This is actually an assembly of the rubber part and the 2 steel bands. I found it in a document in the 1 liter per second documentation, a link to Big Mastercar. I followed that, and then researching on Fernco's website, and then on Triton, which could make the steel bands, plus making some measurements of my own with parts that I found in Agricolor's lab. I was able to get all the dimensions I needed to create a full model of this part. All the information I used, I recorded in a document, so that way, when I'm done with this whole model, not only will it describe exactly how to build the plant to anyone who wants to build a plant, but it'll also show all the decisions I made and all the information that I received. All of that is documented and recorded, so any questions, anyone can look at that and see it. This is another example of something where this is a part of the manifold tube. As you can see, I'm including even small details like the PVC welding here, this black thing. That was something that wasn't in any of the old models, but it's integral to the functionality of it. So I put it in, I got the dimensions from Juan Guzman, who's actually an Agricolor engineer working in Honduras right now. He's helped me a lot, actually. Pretty sure that that's him, but I'm not sure. But anyway, here's an example of where I'm creating models that demonstrate the manufacturing process. These diffusers are created with PVC pipe. You take an aluminum thing, you boil it, and then you jam it into another frame. So not only will I CAD a model of the diffusers, but I also CAD a model of the aluminum and the steel frame that's used to shape it. So that way, someone building the plant can actually see how to make it along with what the final product looks like, which here's a diffuser, the final product. Obviously simple tools like the pot or a saw used to cut it, it's not really important. People know what those look like. So that kind of stuff I wouldn't model, but the things that are integral specifically to building this plant, like the gigantic frame that's used to cut the huge corrugated tube, that's a specific thing, and without understanding how to build that, you won't be able to build the plant properly. Most of what I'm getting is from actually a manual that describes how to manufacture it that Juan gave me. It very clearly outlines how to create the latest iteration of it with every single step, and all of the missing details I'm filling in by consulting the 1 liter per second documentation, and also I'm in communication with Juan, and he's answering all my questions. He's being very helpful. And by the end of the semester, we plan to have the sedimentation tank done, and hopefully not long after we'll have the whole plant CAD. And this is the end of our presentation. Here's all the links to the files. Thanks for watching. Have a good day.